Nvidia has recently released the new 5070 Ti. It is said to give tough competition to the 4070 Ti Super, promising better frame rates and improved ray tracing capabilities at a similar price point. In this video, we'll analyze their key differences, performance metrics, and help you decide which card deserves your money. The RTX 5070 Ti features Nvidia's newest Blackwell architecture, built on TSMC's 5nm manufacturing process. The GB203 GPU packs 45.6 billion transistors into a 378 square millimeter die, representing an evolutionary step from the previous generation. Blackwell's key improvements include unified CUDA cores that support full-rate INT32 operations, 4th generation RT cores, and 5th generation Tensor cores with FP4 support for AI workloads. The RTX 4070 Ti Super uses the Ada Lovelace architecture with its AD103 GPU, fabricated on the same TSMC 4nm process. Despite being a previous generation design, it features a nearly identical transistor count and die size. Ada's architecture focused on improved ray tracing performance with 3rd generation RT cores and 4th generation Tensor cores, but lacks the unified execution model and FP4 acceleration found in Blackwell. The RTX 5070 Ti comes equipped with 8,960 CUDA cores, 280 Tensor cores, and 70 RT cores. It features a base clock of 2300 MHz and a boost clock of 2452 MHz. The most significant improvement comes from its 16 GB of GDDR7 memory running on a 256-bit bus at 28 gigabits per second, delivering an impressive 896 GB per second bandwidth. Additional specifications include 280 texture mapping units, 128 render output units, and a theoretical performance of 43.94 teraflops of FP32 compute power. On the other hand, the 4070 Ti Super features fewer CUDA cores at 8448, along with 264 Tensor cores and 66 RT cores. It compensates with higher clock speeds, 2340 MHz base and 2610 MHz boost. Memory configuration includes 16 GB of GDDR6X on a 256-bit bus running at 21 gigabits per second, resulting in 672 GB per second bandwidth. Despite having fewer cores, its higher clocks allow it to achieve a similar theoretical 44.1 teraflops of FP32 performance, though the memory bandwidth limitation becomes apparent in more demanding workloads. The RTX 5070 Ti introduces multi-frame generation, an advancement over DLSS 3's frame generation that can produce multiple frames simultaneously. The new card supports PCIe 5.0 and features upgraded display connectivity with DisplayPort 2.1b and HDMI 2.1b. Blackwell's Tensor cores support FP4 precision, potentially quadrupling AI throughput compared to FP8 operations, while the shader model has been updated to 6.8 for additional programming capabilities. The RTX 4070 Ti Super supports DLSS 3 with frame generation, but lacks more advanced multi-frame generation capabilities. Display outputs are limited to DisplayPort 1.4a and HDMI 2.1a, restricting maximum resolution and refresh rate combinations. The card uses PCIe 4.0, which remains sufficient for current gaming workloads. Both cards support the full DirectX 12 Ultimate feature set, including mesh shaders and variable rate shading, though Ada Lovelace implements the slightly older shader model 6.7. The RTX 5070 Ti delivers approximately 16.6% better performance on average compared to the 4070 Ti Super across synthetic benchmarks, with the gap widening to 25% in some 4K tests. In gaming scenarios, the 5070 Ti impressively excels at 4K resolution, where its memory subsystem demonstrates clear advantages. The improved ray tracing cores also provide better performance in games utilizing advanced lighting effects. The RTX 4070 Ti Super remains competitive, particularly at 1080p and 1440p, where both cards become more CPU limited. Its higher boost clocks help maintain performance in less demanding titles where memory bandwidth is less critical. The 4070 Ti Super still provides excellent frame rates in most modern games, especially when utilizing DLSS. The RTX 5070 Ti features a redesigned cooling solution that handles its 300-watt TDP efficiently, despite the 15-watt increase over the 4070 Ti Super. Thermal performance remains solid with typical gaming loads, keeping the card around 70 to 75 degrees Celsius in most standard cases. The card utilizes the newer 16-pin connector, which provides sufficient power delivery without the reliability concerns that plagued some higher-power RTX 4090 implementations. The RTX 4070 Ti Super operates at a slightly lower 285-watt TDP, offering marginally better power efficiency in some scenarios. The 4070 Ti Super typically maintains temperatures in the 65 to 70 degrees Celsius range during extended gaming sessions. Both cards implement 0 RPM fan modes at idle for silent operation during low workloads, though the newer 5070 Ti tends to activate its fans at slightly higher temperature thresholds. The RTX 5070 Ti launches at $749, representing a $50 reduction compared to the 4070 Ti Super's original launch price. Despite the lower MSRP, reports indicate very limited launch supply, raising concerns about actual retail availability at advertised prices. The RTX 4070 Ti Super, having been on the market since January 2024, enjoys more stable pricing and better availability. As retailers clear inventory to make room for newer models, discounted pricing on the 4070 Ti Super could make it an attractive alternative for budget-conscious buyers. The choice between these GPUs ultimately depends on your specific needs. Prioritize the 5070 Ti if you demand upgraded performance for 4K gaming and creative workloads, especially if you can wait for supply to stabilize. Choose the 4070 Ti Super if you need immediate availability, primarily game at 1440p, or find it at a significant discount as retailers clear inventory. So, are you thinking about buying any one of these two GPUs? Let us know in the comments below. Thanks for watching. Subscribe for more.